Welcome back to our live coverage of Remars. We are AWS On Air. I'm A.M. Grabelny. I'm a solution architect here at AWS. We've been doing a really, really cool segment here on AWS On Air called the Startup Spotlight, where we've been talking with startups primarily in the machine learning space. And we've got a startup with us today. We've got Krishna from Fiddler. We're going to hear from him in just a moment. But first, Jillian, you must introduce yourself.
Oh, thank you.
Please.
So yeah, my name is Jillian Ford, and I am a startup solutions architect.
So excited always to host with you, Jillian. Thanks.
Yes, this is always fun.
Krishna, this is a reunion of sorts,
Absolutely.
right? We've met before, not in our corporeal forms,
Yeah.
but you were on an episode of a show that I used to run that still airs, by the way.
Yeah.
Just because I'm not on it doesn't mean it went away. Called Howdy Partner.
That's right. Yeah,
Welcome back.
Absolutely. It's great to reconnect, see you in live.
I know, it's great. I
we
exist.
We did the Twitch session 2 years ago when everything was locked down, and and it was fun actually too. And yeah, I mean, I'm really glad to be at Remars and talking about ML ops and ML monitoring and explainable AI. It's a really fun event, and very excited to be here.
Krishna, tell us about what you do at Fiddler and what Fiddler is, please.
Yeah, I'm the founder CEO of Fiddler.ai. We are a model performance monitoring product. We help companies build trust into AI by providing them visibility into how their models are performing, helping them explain how their models work to various stakeholders so that they actually know how their AI systems are working. We believe that this human-to-machine trust is going to be super important for AI to succeed and really operationalize in a big way in the enterprise, and that's what we are enabling for our customers.
Yeah, it's so interesting that you use the words trust and explainable AI. So can you dive into a little bit more about what that means?
Absolutely. So if you think about machine learning or AI systems, right, they're not like traditional software. If I've written a piece of code, I can go and read up the code line by line and understand how it works. I can even debug it and make changes to it. Whereas
You've never read my code, clearly.
Whereas machine learning models are opaque entities. Essentially, they detect patterns out of data and they encode them in arcane structures that humans cannot understand. So what explainable AI provides is gives a lens into the model artifact. If you have, let's say, if you trained a machine learning model to predict credit risk scores of loan applications, let's say the model is rejecting someone's loan application. Why is the model rejecting? That's what explainable AI helps you understand and give you insights so that you can actually provide better customer service, but also go and improve the model if you don't think the model is actually working for you.
Yeah, very nice. To draw parallel to my world over here in DevOps, the push to microservices, right? You can't just drop a breakpoint in a microservice, right? So in the DevOps world, observability grew to be a big critical piece. Sounds like the same is emerging for ML workloads.
Absolutely. So if you think about like in the last decade, DevOps, people broken down their monolithic software applications into microservices, and all of a sudden they had the need for observability around all these microservices really grew, right? And you've seen tools like Datadog, Splunk, get widespread adoption. Same thing is happening with machine learning models. The machine learning model is the new software entity going into production in a big way. And it suffers from this opacity part of it that I talked about. The other problem with machine learning models is, unlike traditional software applications, they kind of wane in performance over time, because they're dependent on the data that they were trained with. And if the situation changes, so let's say if you trained the model before the pandemic, and during the pandemic, lots of things have changed, people lost jobs, businesses foreclosed and whatnot. Now those models may not work exactly the same way. So you need to constantly monitor the model performance so that you know when to retrain the model so that you keep that model performance intact. And those are the two main problems that Fiddler addresses, model monitoring and explainability.
Okay. Yeah, can you maybe explain a little bit more about like what that maybe kind of looks like on the model monitoring and explainability part?
Absolutely. So what we provide is we look at the data that the model is looking at. Let's say the same credit risk model. Let's say it's looking at factors like the loan amount that you're requesting, or your previous debt, or your income, and it's taking all of these variables and predicting a credit score for you. Now what we monitor is we monitor all the inputs that the model is receiving and the output of the model. And we look at shifts in distribution. So we see like, okay, in an aggregate level, are like, what kind of people are applying for the loans? Are high income people are applying or low income people? Let's say you train a model with like a lot of low income applications. Now suddenly the model is working on high income applications. Would it work in the same manner? So that's what we observe. It's called basically monitoring data drift. So you're measuring drift in data, and when that data drifts, you can actually alert the data scientist, hey, like there's basically the inputs that the model is seeing are shifting. So you may look at how the model is working and understand if you really need to retrain it, or if it's performing well across all the segments or across all the loan applications that you're serving. And those are the level of insights which I'm going to demo in a bit that Fiddler offers.
I think we see across the board different levels of maturity in machine learning workloads. Some people are just getting comfortable having the model deployed somewhere to start gaining inference.
Yeah.
They're not even at a point where they can tune that beyond like, no, we're getting inference. That's as good as we can get. How do you, as a company, decide what time is the right time to start getting these deeper metrics and insights into your model?
We think model performance monitoring is critical to get your AI right? Right from day one, when you're pushing your first model to production, you need to make sure that you have proper monitoring in place. Monitoring the data pipelines that are serving the features for your models, monitoring the outputs coming out of the models, being able to understand why the model might be breaking in certain scenarios. Machine learning is a collective exercise, right? Data scientists are building the machine learning model for certain business use case. Maybe they're helping the fraud team detect better fraud. Maybe they're helping marketing team acquire better customers. So there's always a business stakeholder, and they have questions about how machine learning works. So the more transparency and visibility data science and machine learning teams provide, they can accelerate machine learning development and impact the business in a much, much bigger manner. And that is the ROI that Fiddler provides, because we unlock that transparency and increase the model velocity in the organization.
Yeah, so we've got a lot of people listening, and they're probably just learning, AI right now. So model explainability, are these things that they're going to see regardless of the type of machine learning problem that they are starting to learn about?
Yeah, I mean, as I said, these are universal things, right? Essentially, as soon as the moment you start using machine learning for your business in an operational sense, you have a ton of questions to answer. How is it improving my business, right? Is it actually reducing, my business impact, or improving my business impact? I mean, for example, recently we have seen the news of a big housing tech company use machine learning for predicting house prices, and we've seen what happened, right? They've bought a lot of homes that were overpriced, and it turns out that the model was not predicting properly. So if you don't have monitoring in place, those model decisions could be suboptimal for your business. So it's very important for you to do this right from day one, when you're putting your models into production, so that you can actually do it right for your business.
That's a really interesting, I think, divergence from what you would traditionally be monitoring, like in a running application somewhere, right? Like you're monitoring performance in terms of like CPU, or in terms of storage, or whatever, right? Memory usage. No, this is actually the outcomes, right? Am I getting the correct outcomes? Am I like slowly over time getting worse outcomes?
Correct, exactly.
Or better outcomes. That's cool. Can we see actually what this looks like when I work with it?
Yeah, so is my demo on right now?
It should be.
Okay, great. So here is like a monitoring dashboard that I'm going to walk through. This is a random forest model. It's one of the machine learning algorithms to predict an outcome. I'm trying to essentially monitor churn probability. So it's looking at a banking data set, and it's predicting how likely a banking customer is churning from the bank. So you can see here there are two axes. I'm monitoring the average probability of churn here, and then there is basically I'm monitoring the drift in the churn probability. So when I say drift, what it is measuring is how deviant is the model behaving from the time it's trained with. So you want the deviancy to be very close to zero, right? So essentially you want this blue line to be as close to zero as possible, because you want to make sure that your model is working the same way as you train as a data scientist. Now, whenever this actually peaks, this deviancy or drift peaks, you want to get alerted. And you want to be able to understand how things work. And so here, for example, when this goes from 0.1 drift to 0.2, you can set up an alert to actually come and diagnose how the model is working here. And similarly, what Fiddler also provides is monitoring the model's impact on the end business. Here, I want to know, like let's say as a marketing analyst, I want to know how many high-risk users the model is flagging and how many low-risk users the model is flagging on any given day. So you can actually look at that on a given day. And then similarly, what's the accuracy of the model over time? here you can see that at that point where the model drift was peaking, you also saw that the model accuracy was going down. So now you see that there is a correlation between accuracy going down and the drift peaking. So we can now diagnose this a little bit better. One can also monitor data quality aspects of Fiddler. A more popular issue why models go wrong in production is when they receive bad data. So you can have, for example, missing values or range violations or type mismatches, simple errors coming through your data pipelines, that can actually, break the model performance. You can clearly see here there are a couple of features that are broken. There is a feature called estimated salary that is having a bunch of missing values in production data. So whenever that happens,
how do you determine when you are actually in the inferences that you're gaining?
Yeah.
What's wrong inference? Like, what are the factors that these are very obvious factors for sure. Are there any others that are more specific?
Exactly. So we try to look at the common cases where where inputs break down, and we automatically detect those issues. So that in this case, our customers don't have to write rules around, hey, this is what a missing value means, or this is what a type violation means. We are basically looking at the ground truth, like the underlying training data set, and essentially looking at it as a golden set and monitoring the production data, comparing it with the training data set. So now whenever we see an anomaly pop up, we flag it. Oh, there's a missing value violation here. Or there is like a range violation here.
Is there anything happening here for, say, so we've got the high risk, low risk.
Correct.
Let's say there was somebody who was identified as high risk, but was actually low risk.
Right.
Does that data flow back somewhere into Fiddler?
Exactly. So we collect all of this data, so you can actually go and look at, let's say you're seeing accuracy go down. You can look at pockets of population, which I'm going to show, which might be not doing well with the model, and inspect them further. So let's look at this data drift dashboard. So what Fiddler allows you is when you see this peak data drift, you can go and look at what features are contributing to this data drift. This is basically one of the special aspects of Fiddler. Is it not only helps you monitor what's going on, it gives you reasons. Now what it is showing is there is a feature called number of products whose distribution has shifted from training set to the production. So you can see that during the training side, most banking customers were having 1 or 2 products in their portfolio, whereas in production on that day, you see that distribution has shifted, right? Now you can actually go back and verify that. If I go back and verify that, a few days ago, those distributions were almost identical, right? Now, when you go back in time and see like that distribution has changed, we attribute a numerical score. We call it a prediction drift impact. How is this shift actually contributing to the prediction's poor performance, right? And so you can see it's a pretty big impact, 65% impact. So this gives you the ability to troubleshoot the models better and really like find the needle in the haystack. Now what I can do is I can actually export this data into an analytics view and mine this further. This is another interesting aspect of Fiddler. We call it slice and explain, where I can actually slicing the data using traditional SQL. So anyone can use it, from data scientists to analysts to engineers. And so this basically I'm looking at the timestamp that I'm actually mining the data for. And I can analyze the data using a bunch of charts that Fiddler provides.
Oh, cool.
So for example, right now I can look at, okay, what is the accuracy of the model on that time slice? You see that the accuracy of the model is 67.67, right? Now I can go and look at different segments. Let's say I look at like different geographies here that are listed. Let's say I pick like Hawaii, which is a state that I'm seeing at the top. And I'll run like a Hawaiian specific segment. I see that the accuracy of the model is like quite low in Hawaii, right? And if I compare that with the non-Hawaiian segment, you see that the accuracy of non-Hawaii is like very high, 0.81. Now, what we have found is like a segment called Hawaii that seems to have a poor model performance, right? Now we can dig even further to understand it further. So you can look at feature importance and see like in the non-Hawaiian segment, you can compare the production feature importance with the training data set feature importance. So as long as these two bars align, you can say that the model is behaving very well in production data set for this segment. But when I look at the Hawaiian segment, you kind of look at it, these two bars are wonky. The production data is like somewhere there and the training data is here. So now you have found a segment where the model is actually not behaving very well, and you can go and try to figure it out. And so you can do further analysis. I can look at the feature distribution of this particular feature and see like in Hawaii, it's very much skewed towards people using 3 products, whereas like in the non-Hawaiian segment, it's actually the other way around, right? So what this allows is the data scientist or the analyst looking into it to slice and dice very quickly and unlock those poor performing segments and figure out how they can improve the model.
In my world, I would call this root cause analysis.
Exactly.
Right? Like that's what this is.
Exactly.
But and in my world, we have our own tools for conducting root cause analysis
Right.
too. It's cool. I have not seen a tool
Yeah.
like this before for root cause analysis in ML workloads. That's really interesting.
Absolutely.
Yeah, so let's say someone were to then take some actions
Yeah.
based off of like
Yeah.
the data here
Yeah.
that's that's shown. Is there any
Yeah.
place within the tool to be able to
Yeah.
start showing like, okay, this is what I did, and
Yeah.
be able to track
So
results?
one of the things is how do we close the feedback loop right now? What do I
Yeah.
do with this actionable, what do with this insight? So in this case, what I know is there is a particular segment of data where the distribution is off. So first thing I can go is I can check my business team, have we sold more products in the state of Hawaii? If it is that is, or is this a data pipeline error, right? If it's a data pipeline error, I can go and fix that. If it's actually indeed a business change, now I have an opportunity to go retrain the model. So what you can do is I can go and download this Hawaiian data, that Fiddler has collected, and append it to your training data set and retrain your model, right? So that's how you close the feedback loop. So you can not only do that, you can also look at individual explanations. You can look at each, churn probability of each customer in each state, and look at why they might be churning. So you can look at both coarse grain and fine grain. So you can actually, let's say if your marketing team wants to know, hey, why is this customer churning with a 77% probability? They can really know, which factors are dominantly increasing their churn, which factors are dominantly reducing their churn. And they can go try to intervene. So this particular customer is using 2 products, and that's contributing 30% of their churn, right? So what if I do add 3 products to their portfolio? I can run those interventions and see when I did that, the churn probability dropped to 13% from 0.7, right? And you see, by just making one, obviously this is an obvious thing. I sell more products, the customer might not churn, but you can kind of do these interventions to understand what would the model do if I made this change, right? And that also helps the business teams, be more comfortable using machine learning outputs in their business workflows.
Yeah, this drives a real outcome for
Correct.
whoever is maybe the
right.
account manager of
Correct.
this person, right?
Right.
Like, oh, we really need to target an increasing
Right.
adoption of another service.
Yeah, we have several customers like this in Fiddler where they would connect a fraud model to a fraud operations team, or
Yeah.
a churn model to a marketing team. So this is the beauty of it, right? So with Fiddler, you can connect your machine learning teams to your business teams. And that makes the whole this whole, responsible AI happen, AI for your business happen. And that's the exciting part.
Responsible AI. That's a term that you just dropped. What does that mean?
Yeah, so responsible AI is essentially being able to do AI right for your customers and your organization, right? One of the big problems with AI is because it's learning, from various patterns from data, it can pick up
Biased.
It can pick up signals that can instill bias in it. So in this case, for example, I wanted to show an example where I'm looking at a credit approval model. And I'm looking at gender and race as 2 protected attributes, right? And what Fiddler gives you is insights into, how is the model doing across different, demographics. So for example, if I can look at model metrics across intersections of demographics. How is the model doing on female Caucasians versus male Caucasians? Which groups are doing better with respect to true positive rates or true negative rates? And so you can really understand while you're shipping models, how is the model doing across my protected attributes? And that's very important for, especially if you're in a regulated industry like banking or healthcare, it's extremely important to do it. But even for use cases where, let's say you're trying to do customer acquisition, are you being equitable across different demographics? And that's an important thing for teams to consider.
It is. How do I get started?
You can talk to us. We provide a free trial option for customers to come and talk to us. You can email us at info@fiddler.ai, or you can reach out to me personally at krishna@fiddler.ai. We're happy to help you set up and try the product out.
Cool. Very cool. Any upcoming events for Fiddler that you want to talk about? We've got about a minute left.
Absolutely. We are very excited about a major product launch that we are doing in a couple of months.
Oh.
And there's a big announcement that's going to come. So we have added a whole bunch of new features and functionality to the existing product based on the feedback that we've got from our existing customers. And so things around monitoring deep learning models, things around how do we effectively monitor drift in models that detect fraud. Like fraud is a very important area where it's constantly changing. Your adversaries are always trying to game your system.
Oh, yeah.
And so you see a constant drift in fraud models. So it's very important to actually monitor drift properly. So some really interesting new cutting edge technology that we have developed, automatically understanding performance issues in the models, things like that. So they're all getting released in the next couple of months. So it's quite exciting time.
All very exciting. Thank you very much
Thank
for
you.
coming back, Krishna.
Absolutely.
I'm excited to see you again. Jillian, always wonderful to host with you.
Yep.
We'll be right back. Stay tuned.